Hello and welcome to the Inverses Day 2 video. Now in our last video in last class we spent time finding inverses with graphs and equations and on tables and so on and so forth, but now we are proving things are inverses, and there's three different ways to do that. We can prove this graphically or on a graph, prove it symbolically or solving, and using composition, so throwing it back to last week. So we are going to look at a problem, so for instance a here with this specific f of x and this g of x, and we are going to use all three different methods to prove whether these functions are inverses or if they're not inverses. And yes, I do want you to do it three different ways for all of these problems. So as we go through, let's start here graphically. So I'm going to graph both of these functions. Let's see, this one will be in green. Now you can make a table for this if you'd like. So if we were to make a table, I'm gonna zoom in a whole bunch. If we were to make a table for f of x, I'm gonna do that in green here. I'll use the x values -2, -1, 0, 1, and 2. If I was to plug it into this equation, I would get -8, -5, -2, 1, and 4. So you can plot all of these points, but since this is in y equals mx plus b form, you can say that, hey, we're going to have a y-intercept at -2, as we can see in our table, and then we have a slope of 3, so I can move 3 up and 1 to the right, 3 up and 1 to the right. So you may have any of these points that we have listed. So I'm going to make a line for that as straight as I can. There we go. All right, so this is our f of x. And then we can graph our g of x. So our g of x, I think I'm going to do that in, let's do that in blue for our g of x. Now, g of x is a little weird to graph, so if you want to think of it in y equals mx plus b form, you can think of this as 1/3 x plus 2/3. Now, it feels a little weird to have a decimal or a fraction as a y-intercept, so instead I'm going to be picking points that I know that I can plug into this equation and make this a whole number. So for instance, I know, again, I'm going to make a t-table. You don't have to do this, but this is something that might help you. So I know that if I can put something in here to make this add up to something with a multiple of 3, this will come out evenly. So for instance, if I put a 1 in here, 1 plus 2 is going to give me 3, divided by 3 is 1. Okay, so that's a full whole number. So I'm going to put, let's see, 1 here now, that's going to be 1. Other numbers, if I plug a 4 in there or 7 in there, if I plug in a -2 or a -5, I'm just kind of going through this quickly because teacher knowledge, I know what numbers I can plug in. So if I plug in any of these numbers into the numerator, I know I'm going to get a whole value as my y value. If you plug in something like 2, you can certainly do that, but you will be getting some sort of fraction or decimal. So from here, when I plug in these x values, for -5, I'm going to get -1. For -2, I'm going to get 0. For 4, I'm going to get 2. And 7, I'm going to get 3. So let's see, when we plot these points, we have -5, -1, -2, 0, 1, 1. Those overlap. That is totally okay. You can also pick a point and then notice that our slope is 1/3. So from a point here, you can go up 1 and over to the right 3. That is a method you can use. But these are all the possible points you may have on here. And again, this is our g of x. So if you take a look at where it says graphically, what can we do? It says graph both the original and inverse and show their reflections across the line y is equal to x. So let's graph that line y is equal to x right here. And as I graph that line, I see that, hey, you know what? These are in fact reflections of each other. So if they are reflections of each other, you know what? Let's write a conclusion statement. I'm going to do that off to the side over here. So let's see. Since f of x is a reflection of g of x over the line y is equal to x. So since they are reflections of each other over this line, what does it mean? Well, it means these functions are, excuse me, inverses of each other. There we go. So hey, we showed, yes, these are reflections of each other, so they're inverses. We've shown graphically, we've written our conclusion statement. So now that we know that these are inverses, as we go through and check this problem symbolically, meaning we're algebraically trying to find the inverses, as well as through composition, we know that these should work. If they don't, it means that we've gone wrong somewhere. So let's try our two other methods. If we go through this symbolically, I'm going to move this to the side and zoom in a little bit. We're going to be taking our 4 steps of finding inverses for both of these equations. Don't just do it with one. So for our first step, we replace f of x with y. Second step is that we switch our x and our y value. So we get x is equal to 3y minus 2. Next step, try to get y by itself. So in this case, we are going to add 2 to both sides and then divide both sides by 3. Very last step is to replace y with f inverse of x. So we have f inverse of x is x plus 2 over 3. Let's see what we get when we try to find g inverse of x. And again, same steps. We're going to replace g of x with y. Then we are going to switch our x and our y value. So we get x is equal to y plus 2 over 3. Now we're going to try to solve and get y by itself. So we're going to multiply by 3 on both sides, and we're going to subtract 2 on both sides. Very last step is to replace y, normally with f inverse of x, but in this case, since it's g, it's going to be g inverse of x is equal to 3x minus 2. Now I take a look at that and go, hey, we just found the inverse of both of our functions, and you may notice that, hey, f of x, well, we got the same thing when we solved for g inverse of x. And our g of x, we got the same thing when we solved for f inverse of x. So if we were to write a conclusion statement here, we can say, well, since f inverse of x is equal to g of x, and g inverse of x is equal to f of x, these functions are inverses of each other. So we were able to show symbolically or algebraically that yes, once we solve for the inverses of these two functions, we end up getting the opposite's original function. So this is how you'd solve symbolically. Last, we're going to show through composition, and it says specifically, show that f of g of x is equal to x, and g of f of x is equal to x. That's because when you're using composition, if they are inverses, they're going to start to undo and do the opposite for all of the operations, and we're going to be left with only x. So let's see how this works for us. Whoops. So let's try with g of x. F of g of x. So if we try f of g of x, so remember we're going to plug this function inside of our f function. So we're going to have 3 times x plus 2 over 3 minus 2. Sorry, I know that parenthesis got a little off. Well, let's do that. There we go. Okay, so from here, I'm going to multiply in the 3 since we're multiplying by 3 and dividing by 3. Those are going to cancel out, and we'll be left with x plus 2 minus 2. And then we have a plus 2 and a minus 2, and those cancel out, and we're just left with x. So they're undoing each other and we're just left with its most simple function. Let's try this the other way. If we do g of f of x, excuse me, there we go. G of f of x, that means that we are putting f of x inside of our g of x function. So this is going to be, let's see, 3x minus 2 plus 2 over 3. So we are plugging in f of x inside g of x. From here, starting with the numerator, we have that minus 2 and that plus 2. So this is going to become 3x over 3, multiplying by 3 dividing by 3. These cancel out, and they both get us x. Yes, you do have to show in both directions because that means that we can say that since f of g of x is equal to x, and g of f of x is equal to x, you can say then these functions, or you can just say then f of x and g of x are inverses of each other. And so this was one full problem showing how we can find inverses, or prove things are inverses, through graphing, symbolically, and through composition. So let's try this once more. We're gonna move down to problem C right here. Let's do the same thing. Let's start graphically. So if we're going to graph f of x, you can use a table if you want, or you can also notice, again, y equals mx plus b. Our y-intercept is going to be at 6, and we have a slope of 2, so we'll move up 2 to the right 1, up 2 to the right 1. If we were to make this into a table, and we use the points -2, -1, 0, 1, and 2. We already have a few of these values, so for 2, the y value is 10. For 1, the y value is 8, 6. And then you notice it kind of just keeps going down by 2 since that's the slope. So 4 and 2. So we can plot the rest of those points. I don't know exactly which ones you used, so I'm going to plot them all the way down. Even if you don't have points going all the way down, please make sure that you're graphing from one end to the other, because this is going to better help us see those reflections. This is that line, f of x. Then we will also graph g of x. Now g of x, again, is in a fraction. So if we were to write this in y equals mx plus b form, this would be 1/2 x plus 3. So if you were to write this, or if you were to graph this using that, we would say that our y-intercept is at 3. And then our slope is 1/2. So we go up 1 to the right 2, up 1 to the right 2, and we continue with these points here. We can also go to the left 2, down 1. So it looks something like this. Whoop, there we go. And if you had a table for this, might look something like this. So if we use, I don't know if I'll use -2, -1, 0, 1, just because some of those will be fractions. Since I'm going to use -4, -2, 0, 2, and 4. We have all those points here. Those y values are just 1, 2, 3, 4, 5. So if you don't want to do a t-table, you do not have to. You can just graph it like this if you'd like. But we can see that if we were to graph the line y is equal to x across here, so again, this is the line y is equal to x, that line of reflection, we can see that, you know what? These lines do not reflect across that line of y is equal to x. They do not reflect upon each other. So what does that mean? Well, if we were to write a sentence and say, you'll notice I start all my sentences with since. You don't have to do that, but I'm going to say since f of x isn't a reflection of g of x over the line y is equal to x, the functions are not, I'm going to capitalize it and underline it, not inverses of each other. And so that's important. If it's not reflective over the line y is equal to x, they're not inverses. And if you find that something isn't an inverse, that's okay. Now we just have to show symbolically as well as through composition that these are not inverses. So let's first go to symbolically and try to solve in both directions. So I'm going to move this over. There we go. So if we take a look at f of x, again our steps, replace f of x with y. Switch your x and your y values. We're always going to be doing that with inverses. So we have x is equal to 2y plus 6. Next, I want you to solve to get y by itself. So we are going to subtract 6 on both sides. Then we're going to divide both sides by 2. So we get x minus 6 over 2 is equal to y. Very last step, replace y with f inverse of x for notation. So f inverse of x is equal to x minus 6 over 2. So we found f inverse of x. Let's try to find g inverse of x. So again, same steps. Replace g of x with y. Switch your x and your y values. So we get x is equal to y plus 6 over 2. Now to get y by itself, I'm going to multiply both sides by 2 and subtract 6 on both sides. Lastly, I'm going to replace y with, in this case, g inverse of x. So we have g inverse of x is equal to 2x minus 6. So we have found the inverses for both of our functions. And last time we were like, oh yeah, they're exactly the same. But if I look at f of x to g inverse of x, I'm like, oh, nope, those are not the same thing. F of x is plus 6 and g inverse of x is minus 6. Same thing, if we looked at g of x to f inverse of x, we're like, oh, yeah, this plus 6 and minus 6, those are not the same. So in our conclusion statement, we can say, since f inverse of x doesn't equal g of x, and g inverse of x doesn't equal f of x, these functions are not inverses of each other. So again, we were able to show that they're not inverses of each other. If we found that they were inverses of each other, when we hadn't found that graphically, we'd have to make sure to go back and check our work. But there is one more method we have to use, and that is through composition. So we are going to have, let's see, how did I do these? F of g of x, where we are going to plug g of x inside of f of x. So it's going to look like 2 times x plus 6 over 2 plus 6. So first I see I'm multiplying by 2 and dividing by 2, so those are going to cancel out. We'll get x plus 6 plus 6. So we end up with x plus 12. There's something extra there that wasn't able to cancel. So let's see if that happens the other way as well. With g of f of x. We're now going to plug f of x inside of our g of x. So we're going to have 2x plus 6 plus 6 in my numerator over 2. When I take a look here, we got 6 plus 6. So my numerator is 2x plus 12 over 2. When I divide everything by 2, I get x plus 6. So again, it's not just x. Everything wasn't able to undo itself. So we can say, again, since, you'll notice that's how I always start my sentences, f of g of x, we can just say it does not equal x. Doesn't matter what they equal, it just matters whether it's x or not x. So since f of g of x does not equal x, and g of f of x does not equal x, f of x and g of x are not inverses of each other. So writing that conclusion statement is important because if you are going through this work and then you're just like, okay, I'm done. Well, if you don't explain to me what all this means, there's a mix in communication there. So make sure you're showing that to me. But those are the only two problems from this section we're going to go over. We just have two more very fast problems I want to go over with you. One involving graphs, one involving tables, and then we will be done. So thank you for sticking around with me. We are going to move this to its natural size and move it up. Like I said, we're going to be moving to these tables down here. They're both labeled 7A. That is completely my bad. This should be a B right here, but we're actually going to be working on this problem here. So it says, if possible, find f inverse of 5 and g inverse of 6 using the tables below. So f inverse of 5, I'm going to do my work down here. F inverse of 5, normally whatever is inside that parentheses is x, but since we're using f inverse of 5, remember we switch our x and y's. So this is now our y value, and I'm looking for the x value. So instead of looking x and going down, we're going to look at our y values. Oh, I see 5, and we go up. So we're starting with our y's and going to our x. So f inverse of 5 is equal to 4. So we were able to find that. Now for the next one, g inverse of x, or g inverse of 6, again, we're looking at our y and trying to find the x. So I look along here and I go, oh, look, there's two places where there's 6's. So there's two x's that are going to work. One of them is 1, one of them is 5. Got 1, and we also have g inverse of 6 is equal to 5. Now the next question is determining if f of x and g of x are functions. Looking here, they are both functions because every x value has exactly one y value. So I'm going to say this is a function. I'm going to say that this is also a function, but looking at the y values for g of x, they had more than one x value. So it means that its inverse is not a function. So we can say it's a function, but not a one-to-one function. So keep that in mind. I know this has been a long video. Thank you for sticking around. One more problem. I want to look at a graph. So if we go down to problem number 8, I just want to take a look at problem A, and that's it. So we're going to graph one-to-one functions. And first it says sketch the graph of f inverse. So if this is my graph right here, and I want this to be reflected over the line y is equal to x, it has to be reflected over this line. I can switch these x and y values here of, let's see, this one is 0, 2. This one's negative 2, 0. So those are going to become, let's see, 2, 0 and 0, negative 2 right here. And to make sure to graph along that line all the way through. So we can see that they are in fact reflections. Next, it asks us to find the domain and range of f of x. Well, from here, it looks like these lines are going on and on forever. So for our original function, let's do that here, f of x, the domain is from negative infinity to positive infinity because there's no break in our x values. And our range, bottom to top, also doesn't seem to be any breaks. So it's from negative infinity to positive infinity. Now if we define the domain and range of f inverse of x, remember, domain is x and range is y. And when we've been finding our inverses, all we've been doing is switching our x and our y. Now in this case, the domain and range are the same, But if we were to just switch the domain and range for f of x, we would get the range and domain for f inverse of x. So the domain for f inverse of x is negative infinity to infinity, and the range for f inverse of x is negative infinity to infinity. When we go over this in class, mainly part C, you'll see a little bit more about what I mean. Thank you for sticking around in this video. If you have any questions, let me know, and I look forward to seeing you tomorrow.